Hi everyone, welcome to those that are joining us on the Honey, I Shrunk the NASA Payload Challenge webinar. We are really excited to have you here. We're going to give everyone just a few minutes to join before we get started. While we're waiting, we'd love to know who is attending this webinar. Please just post in the chat, let us know where you're calling in from. It's always great to know who we have here. Andrew, whereabouts in the world are you right now?
I'm in Glendale, California, about 3 miles away from the Jet Propulsion Laboratory.
Awesome. A nice short commute when you're commuting and not working from home.
It is.
Kevin, how about you?
I'm in Yorktown, Virginia, just a mile away from the site of the Yorktown battle and about 10 miles away from Langley Research Center, the first NASA center.
Awesome. And Saba, what about yourself?
I'm calling in from Claremont, California. It's about 35 miles east of Pasadena in JPL.
You've got a much longer commute than Andrew does.
I do.
Wonderful. I'm seeing people from all over joining us. We've got a few people from California, Spain, Chile, UK, Portland. Awesome. So I first of all would just like to welcome everyone to the challenge webinar. We're really excited to have you here and to be able to answer some questions for you today. In a minute, we're going to go through some introductions and then I'll pass it over to Saba, who will walk you through a competition overview. But just before I do, I'd like to share a little bit about how you can interact with this webinar. So as many of you have now noticed, there is a chat that is on the right, that's just along the bottom of your Zoom screen. We'll also be taking questions, and we will be taking questions through an app called Slido. So I will post that link in the chat a few times today. If you have any questions, please go in and post them there. And also vote up the questions that are most important to you to get an answer for. We'll be starting at the top of our list and working our way down through it. So with that, why don't we start on introductions? Very briefly, my name is Kyla Jeffrey. I'm the Director of Customer Success with HeroX and really pleased to be supporting the team at NASA and JPL. Saba, I'll pass it to you for an introduction and then we can introduce Andrew and Kevin as well before jumping into what you have to share with us today.
Yeah, sounds good. So my name is Saba Bucks. I'm a technologist at JPL and I'm one of the challenge leads.
I'm Andrew Shapiro. I'm the manager of the technology formulation at JPL, and I'm one of the instigators of this project.
Oh, and we have lost Kevin's audio just in time for him to give us an introduction.
Oh, hey, sorry.
There we go.
Yeah, I'm Kevin Kempton. I'm from the Game Changing Program Office at NASA Langley. We develop new technologies that take them from the lab and get them into a readiness for flight. And so this competition is right along the lines of game-changing technology. Hopefully the teams will innovate something new, and hopefully in the next phase we can move these off to flight if they get selected.
Wonderful, thanks Kevin. Okay, Saba, I'll pass it over to you.
Great, thanks Kyla. Let me go ahead and share my screen. All right, hopefully you guys are seeing my PowerPoint presentation.
We are, looks good.
Excellent. All right. So, well, hello, everyone. So great opportunity to interact with you guys on our challenge on Honey, I Shrunk the NASA Payload. So Andrew and I will be tag teaming the presentation. So before we get into the details, just get to the next slide. So Andrew, you want to go ahead and give a background?
Sure. So what started this challenge is something we observed with some of the NASA payloads. NASA is engaged in the Artemis program, which is a much larger lunar strategy. A subset of that is the CLIPS program, which is the commercial landers. And the commercial landers, there are several of them that have been awarded, and those are being built as we speak. Each of these commercial landers will have some kind of payload. And what we're trying to do is develop appropriate payloads. Some of the payloads we think will be small rovers, and there are several different kinds of rovers that we know about that are in development, and each of these rovers could go explore the lunar surface. And that exploration, they will be doing some measurements, and what we're looking for are very, very small payloads to take different kinds of scientific measurements that will be useful to the larger program in the long run. So things that scientists would like to know, things that the astronauts would like to know, and then demonstrations of technologies that we'll be able to use in the future missions for NASA.
Sounds good. Thanks, Andrew, for the background. So I'll go into a little bit more of the details. So as Andrew mentioned, the Artemis program, so NASA is seeking to put astronauts back on the moon. But before we do that, we want to understand the lunar landscape and resources for a lunar environment, and more so than what we did in the Apollo days. And so what this involves is kind of having an identification of the resources, so potentially water and other minerals, mapping the terrain, exploration, understanding the radiation flux at the surface. These are all things that we're still kind of baselining from back in the Apollo days. And so if we're actually thinking of having a lunar colony or a lunar base, it'd be good to know how we can actually survive and live on the moon. Now, in terms of lunar exploration, there's actually a big fleet of rovers that are being currently developed both at NASA and with our commercial partners. And so a few of these examples are listed here. So we have a bigger class rover known as NASA Viper that's being developed out of NASA Ames. Astrobotic has a small cube rover that is a smaller payload mobile platform that is with their Peregrine lander. Blue Origin is developing the Blue Moon rover. And at NASA at JPL, we're also developing a small mobile type pop-up rover known as Puffer. And so we have a fleet of different size rovers for lunar exploration. And so in order to do the science and understand the resource utilization, we'd like to go ahead and develop small payloads. So as I mentioned before, NASA and our commercial partners are developing smaller, more mobile platforms. Potentially one mission concept could be to have a swarm type of micro rovers the size of a Roomba and that are exploring the lunar terrain and working together. Now with these smaller platforms, we need to have miniaturized instrument payloads. And the payloads that we're looking at are on the order of a bar of soap. Now typically scientific payloads can be up to hundreds of kilograms or larger, and they're really, really voluminous. And so what we're asking for in this challenge is developing payloads that are small, on the order of the size of a bar of soap, that can go on these smaller mobile platforms. And the other thing that we're asking for in the challenge is that, as many of you guys are familiar with the Artemis program, is that we want to have our prototypes and our rovers ready for flight in 2 years to be actually exploring the lunar surface. Now, another thing that we're looking for in the challenge is that we are looking for something that is a TRL 3 or higher. So TRL stands for the technology readiness level, and the technology readiness level specifically to NASA is generally defined over here. And so the definition for a TRL 3 is an analytical experiment and critical function and or characteristic proof of concept being demonstrated. And so what we're trying to do is, in this challenge, is identify technologies that are already at TRL 3, so a working prototype, or at least a proof of concept, and then work our way up to TRL 6, which would be a working prototype ready for flight demonstration. Now, in terms of the mission duration and payload guidelines, these things are better specified in our payload user guide. So the landing time frame that we're looking at is lunar mid-morning, and the mission lifetime would be on the order of lunar mid-morning to lunar noon, with an extended mission stretch goal of 30 lunar days. Now, the payload dimensions, as we mentioned before, is on the order of 100 millimeters by 100 millimeters by 50 millimeters for the exterior envelope, and the mass is a do not exceed of about 0.4 kilograms or 400 grams. Now, additional details and specifications for the payload dimensions and the payload requirements are specified in the payload user's guide. Now, in terms of the small payload structure and timeline, so right now we're in the ideation phase, which will be completed at the end of June 20, or mid-June, actually, I'm sorry, early June 2020. Phase 2 would be the payload development and prototyping, which would start some point in fall 2020. And phase 3 would be the payload integration in spring of 22. The launch window that we have identified for the near term is in summer 2022. Now, for the phase 1 ideation, as many of you are familiar with, the final submissions are due on June 8th of this year at 2 p.m. Pacific Daylight Time, and the awards will be announced July 14th. Now, this is the round 1, phase 1 ideation. The phase 2, which will actually be focusing more on the development, will be announced in fall of 2020. Now, in terms of the prize structure for the challenges, we have prizes up to $160K across 2 categories, lunar resource potential and lunar environment. So the first prize can be up to is $30,000, with 1 award being at that point, 3 prizes at $15K each, and 5 prizes at $5K each with both categories. And with that, I'd like to just conclude our brief presentation. I will be happy to take any questions that you guys have.
Awesome. Thanks so much, Saba. If you stop my screen share, perfect. You're already ahead of me. I'm just going to share the HeroX page so everyone knows where they can find information after this webinar. So hopefully everyone's seen this before. I would highly encourage you to read the challenge guidelines. If you've already read them again before you submit your entry. We worked very closely with this team to put together the guidelines to make sure that we were specific in what we were looking for and guiding you in the right direction. One thing I would like to point out is the judging criteria. This is a good thing for you to look at once you've completed your submission to make sure you're addressing all of the different things that we will be evaluating your entry on. A few other places for you to make sure you're looking. One is the resources tab, where you can find that small lunar payload user's guide that Saba mentioned earlier. There is also a forum, and in the forum you can post any questions that you have. Please do search the forum first to make sure that you've looked to see if your question's already been addressed before asking it. And finally, the update section is where we'll post a recording of this webinar, and if you're already signed up for the challenge, you'll get an email notification about it. The timeline, the submission deadline is due June 8th. As Saba mentioned, that's coming up very quickly. So I highly encourage you to start your submission. And in order to do this, you just click this big orange button, which will allow you to register for the competition. You'll have to accept the legal agreement, and then you can decide if you would like to compete as a team. And you'll see this orange button now says begin entry. You can click on that to begin your submission, edit it at any point up until the submission deadline, and then submit your final entry when you're ready to go. But I do highly encourage you to open up the submission form and start working in it to make sure that you're clear what's available to you and what your entry should look like. With that, we're going to transition into our Q&A session. For anyone that's just joining us, please post your questions in the Slido app. I've just put the link in chat. Also vote up your favorite questions because we'll be starting at the top of the list and making our way down. Any questions you put in the chat box, we will unfortunately not be able to answer. We will be going through those questions that are in Slido. Okay, so my first question, what is NASA's plan to do with the winner concepts regarding funding, support, and implementation? Can the winning teams continue their ideas in collaboration with NASA?
So that's a great question. As Saba mentioned in a presentation, there will be a next phase coming this fall, and we're hoping to have the guidelines of that done this summer. And that will be an opportunity to move into the next development phase of the concepts. And that will definitely provide an opportunity to work with the NASA teams moving forward.
Awesome, thanks, Andrew. Lots of exciting things to come after this project. Okay, we've had a few questions about kind of casings for payloads. Are there any suggested casing around the payload that competitors should continue or should consider for mechanical or dust protection?
Yeah, I'll add certainly MLI, multi-layer insulation, if you want to do thermal management on your payload. It's very good stuff, but it has a definite thickness, so it's going to eat into your volume a little bit. But it will really help with the thermal management. Plus, it will protect against any dust impacts and may prevent lunar dust contamination onto your payload. But remember, these are supposed to be packaged payloads. And so you should have them packaged. They might not be plug and play, but something that can be bolted on. So you'll want to protect your electronics in some way possible. And there's multiple materials you can use to do it, but you definitely want to look at, you know, the NASA material list. You don't want plastics that might outgas and they can't withstand the lunar environment. And there's a lot of guidelines on NASA websites that you can do a search to find recommended materials.
Great, thanks, Kevin. Okay, question about power. So how long approximately will the rover mobility operations take during which its payload will be unpowered? And then in addition to that, how long can the rover actually power its payload for?
Well, we haven't picked a specific rover yet. The rovers are all being developed. But most of the rovers that we're looking at are solar powered, and they'll be working through the solar day portion of the mission. Certainly the first few hours, few days of the mission, a lunar day is going to be about 15 Earth days, and we're looking to deploy in the first couple of lunar days once the lander lands. So there should be time for continuous operation for a couple of lunar days. I'm sorry, a couple of Earth days, not lunar days. My apologies.
Great, thanks, Andrew. Okay, this is almost a follow-up on our first question. Are CLIPS or other direct NASA funds available to help bring the winner's submissions into practice?
There's a competition called PRISM, and we submitted an entry into the PRISM competition for integration into the CLIPS payload specifically for this challenge. So if we do get awarded that, then there will be funding for the integration directly from the challenge.
Great, thanks, Andrew. Okay, now can you tell me more about the rover? What will be the speed of the rover?
Well, as I mentioned earlier, go ahead, Kevin, please.
Well, I was going to say the rover hasn't been fully developed, and there's several different options out there. But the speed is going to be highly dependent on the terrain where it's operating. It's going to be highly dependent on the operations, mission operations, how much autonomy it has. And so, you know, the payload providers, you know, they're going to put in some type of concept of operation. It's not going to, you can see we've have multiple rovers on Mars, and remember the little Sojourner rover that JPL had sent, moved very, very slowly. The newer rovers will move a little bit more snappy because they have some of these onboard navigation capabilities and stuff. But right now, it's going to be dependent on a lot of things, and so it's hard to say what I don't know if the person asking the question is interested in maximum speed or average speed, but it's hard to give a definite number on that.
Great, thanks, Kevin. And I think that might be a bit of a theme for responses about the rover throughout this Q&A, is that you're still selecting which rover and they're still under development. So we don't necessarily have all of the specifics you may be asking for. Okay, my next question is, what type and energy of radiation is NASA interested in? Is gamma mapping of specific interest? If so, what is the performance of the LETS detector to gamma?
That's an interesting question. Actually, NASA is interested in all kinds of radiation, measuring all kinds of radiation on the lunar surface, because they'd like to know what the variation is that the astronauts will be seeing. The Apollo missions gave us a relatively short snapshot of what was going on the lunar surface, and we like to have better knowledge. In terms of a specific detector, we don't have information on that right now. We can look into it and comment later.
Yeah, as far as I'll add a little bit. I mean, you know, you got the galactic cosmic background radiation, which is key for astronauts, but that also causes secondary particles, which is very important for measurement, because you can measure the neutrons and secondary particles, get an idea of what's in the regolith, you know, because the cosmic rays will break up the nuclei, especially if there's hydrogen materials in the regolith. You know, you can measure the velocities. If you have a neutron spectrometer, it's very important. Things like solar energetic particles and like galactic cosmic ray background, especially right near the surface. We've measured all that from orbit, but on the surface near the poles and in some of these areas, it's very important for astronaut health to understand how much protection they need and other things like that. And there's other types of radiation out there, but those are some of the key ones.
Great, thanks, Kevin. Okay, what level of technicality are you looking for in the submissions? For example, composition, graphics, other illustrations, what should that look like?
So these are pretty well defined on the HeroX submission site, so I'd recommend looking into that, and specifically the judging criteria that has been set forward. So the more information you have, the better.
Yeah, I'll add that graphics and illustrations are great for communicating your concept to the judges and really letting them understand what you're trying to convey. But it's not required. If you look at the assessment criteria, it's not a requirement on the quality of graphics or anything, but it's recommended to help give your proposals the very clear understanding for the judges.
Great, thanks, Kevin and Saba. Okay, another question about the actual payload itself. Is designing the housing structure for the payload part of the challenge, or the box is provided, so to speak, and the challenge is only about designing what goes inside that box?
I mean, if either of you guys want to answer, but like I said, in the challenge, it is looking for packaged payloads, and by package, it means that they should be able to be integrated onto the rover with as little integration as possible. So if you come with a bag of components and expect it to be integrated on the rover, that's not what we're looking for. So the packaging, you know, it would be some self-contained box that, you know, like a typical, it could be bolted onto either the surface of the rover or in some type of payload bay. So you'll want some packaging on it, and I've talked about the MOI also to help. The packaging will help protect your payload from the lunar environment, which can be very difficult for avionics and things like that. So you may want to consider that.
Thanks, Kevin. Okay, now what about payloads that are already out there? Are there any that are currently approved for, and for which rover?
There are no current payloads that I'm aware of that are approved for any of the rovers. I know that they were looking at developing a number of them. but certainly none that fall into this class. Most of the payloads that they are looking at in the development cycle are much larger and much heavier for kind of larger vehicles or for the landing platform. So this is a fairly unique call in terms of looking for very small, very lightweight payloads.
Great, thank you.
Yeah, I'll
Go ahead.
add that these are even smaller. If you go look on the NASA site, we had a game-changing big idea challenge where we were looking for payloads to go onto CLPS landers. In the CLPS landers, we gave a limit of 15 kilograms for these payloads. For these miniature rovers, we're setting the bar even lower, I guess, so that you got to really push the envelope to come up with payloads in this scale that we're looking for.
Thanks, Kevin. So some instruments require to be exposed to the open sky. Can we have a lid on the box that opens and closes?
Sure, there's nothing wrong with that. An opening lid is perfectly acceptable and might be a great way to have your payload protected through all of the launch and landing and deployment sequences. And then when you're ready to make your measurement, you can open it up and make your measurement. Sure, that sounds like a great idea.
Yeah, I'll just add that maybe the payload provider should consider that any additional mechanisms like that are the responsibility of the payload provider and not the responsibility of the rover developers.
Got it, thank you. I have a few questions kind of in the same vein, so I'm going to ask them now. Some instruments require that the detector be in direct contact with the lunar regolith. Can you push the box against the surface when the rover is stationary?
So there are different ways of putting detectors directly on the surface, whether it's through a small arm or through some kind of mechanism moving the box. I think in this case, probably the person providing the payload would have to create the mechanism to move it from the box down to the surface. But certainly it's reasonable to be able to put a detector near the surface or on the surface for a short period of time.
Okay, follow up to that question, exactly how deep do we need to dig for the mission if we're going to do depth analysis?
Saba, you've been talking to the lunar scientists?
Well, it depends on what kind of information you're looking for on the payload. So like Andrew mentioned, the digging part of it will probably require an arm. So it'll be dependent on whatever is defined by the payload. So it could be as little, as shallow as a few millimeters or as deep as several centimeters.
And that's a follow-up. The lunar scientists and near the permanently shadowed regions or by the poles, they really don't know. And some of it is they believe that the soil is pretty much desiccated, which means there's no water right on the very surface. But they don't know how far they have to go below the surface to get to water. Maybe if the sensor could look at the wheel tracks, if the rover turned up some soil or regolith. But yeah, that's a good question because we really don't know on some of these things.
Okay, great. A bit of a different question now. Can you talk about who the judges are for the competition? What's their background in this?
Sure, Saba, do you want to talk to that?
Yeah, so the judges for the background are throughout JPL as well as NASA and external partners as well. Everybody that we have on the panel is, there's going to be 2 rounds of judging. They're all technical with various backgrounds from engineering to pure science to actual sensor and instrument development, as well as another round of judges at the headquarters level. And everyone has a technical background, and they'll be evaluating your proposals.
Awesome, thank you. Okay, is there a limit to the number of bots that can be working simultaneously on the moon? If the number is small, can they be 3D manufactured on the moon?
So that's a fun question. They can, as far as we know, there's no limit if you can fall within the mass range. So they would have to be pretty small if you wanted more than a couple. So there are a number of rovers that are planned to go on the moon. In terms of being manufactured on the moon, that's a whole nother challenge in itself. It's a very significant undertaking. I think that that's something that NASA would eventually like to do, but I think that that's several years in the future.
Yeah, I'll just add, remember that this competition, we're looking for sensors that can be put on these rovers in a fairly near term. And so some of the technologies like manufacturing rovers on the moon is probably not going to be near term. It may be, 10 years away, 7 to 10 years, but it's probably not in the 3 to 4 year time frame.
Got it. So we have another fun question. Would NASA consider any rover similar to WALL-E if full permission is granted by Disney Studios? It's cute, agile, and smart.
Yeah, I'll say we'd be more than glad to see something like WALL-E if it fits in the mass power and volume constraints that you guys can build it. It'd be great to see that.
It'll be a lot of fun.
Awesome. Okay. So next question, we're getting a little more serious now. So talking about contactless odometry, how can we trace data from the wheel for angular and linear movement? How does visual or image odometry work with low power consumption?
So that's one of the things that we expect the rover to provide. The ones that we're looking at right now will probably have visual odometry, where they have their own camera system, probably a pair of cameras, and they use landmarks in the images as they see them moving along to calculate the distances that the rover would move. And that information should be available back to the payload in terms of the location of the rover relative to where it started.
Great, thanks, Andrew. Okay, my next question. Can anyone tell about the usage of Airborne R series connector? And do we have to specify connection of the P1 connector to the computing board that we will be using?
So there is a drawing and specification that the entry should look at. Kevin, did you have a comment on that?
Yeah, I was just going to add that I think Kayla had mentioned about the connector to their board. We're not really interested in, consider your payloads black boxes. We don't need to see what's inside those boxes. But yeah, the connectors, the rovers are still under development, and certainly take your best shot at the specific flight connector. And it's more than likely if given enough time, the rover developers could adapt, could adjust their design to accommodate specific connectors. But certainly look at the ICD. It's got a lot of information in there, and if there's something specific, take a best guess at it. And if it's credible, the technical experts will know.
Great, thanks, Kevin. Okay, another question about what a submission should contain. Is it necessary to provide code that will be used for the analysis or operation? Like, for example, this challenge is about ideation, payload design, equipment used. Do we also need to provide code?
I'm not sure I understand the question exactly, but in terms of code, if there's code needed to operate a particular instrument, a sequence of that kind of thing, that will need to be provided so that they can interface to the specific rover. But beyond that, I don't think we need any code.
Well, we might need more information in the phase 2. just in terms of how do we integrate it with our rover. So it might be relevant for phase 2.
Yeah, great point, Saba.
Yeah,
I think, go ahead, Kevin.
Yeah. I just say that in the phase 2, if you're looking for a payload that's going to be flown, they want to have confidence that it'll work, and so you would expect code reviews, but the code ownership, I don't know yet. That's sort of to be determined if that code will be for government use only, or there's a lot of software usage agreements out there. But certainly plan on having it reviewed to make sure you can build confidence. And as Andrew said, and certainly the telemetry that goes back and forth will have to comply with a rover to payload ICD.
Great, thanks, Kevin. I think I would also just encourage everyone to look at the technical readiness level scale, and knowing, at the moment we're at an ideation challenge, but the intent is certainly to be able to progress from TRL3 to TRL6 as fast as possible. So as much as you can provide on things like code that might be needed in the future, that would certainly be helpful. Okay, are microbiological experiments allowed? If so, this would involve a small sample of living cells that might be kept alive in a growth medium. Does that seem practical?
I think, Kevin, you had a good response for this.
Yeah, well, I'll just say that, if you go look at the planetary protection requirements for different places, the moon's is pretty light. The planet, there's not expected to be any life that can survive on the surface of the moon. And so I don't see any issues with bringing living tissue, but I think Andrew mentioned the integration of the payload to try to keep these things alive, because a lot of times, this thing gets integrated onto it'll get integrated onto the rover, it'll get integrated onto the lander, which will get integrated into a spacecraft, and the thought of trying to keep living cells alive for that type of activity is going to be a challenge. I mean, it may be that you could freeze it, but I don't know. You'll have to think about the real operational issues of the payload integration and actually getting it to the moon. It's going to be a real challenge to keep things alive.
Got it. Thanks, Kevin. Okay, this next question, I might need some help interpreting, but although you are looking for packaged payloads, the proposed connector and drawing in the user guide is not compatible with a hard payload package or case. Why?
I don't know. I think it should be compatible with a hard package payload. I'm not sure why they might think that. We might have to take more details for that question offline, but a hard case should be fine. I think the drawings only specify a connector and tell us where the bolt holes are. Other than that, I think we're good.
Okay, so we will look into that further. If anything's different than what Andrew just shared, we'll make sure that we post that when we post the recording of the webinar. Thanks, Andrew. Okay, does NASA allow the payload to have its own power source in case it's required to have more power to operate? For example, a built-in solar panel.
I don't think we have any restrictions per se. I mean, there will be some, you'll have to demonstrate how the batteries will survive, what type of batteries you'll have, and also keep in mind your maximum not to exceed dimensions of 100 millimeter by 100 millimeter and 400 grams are your limitations. So the power that will be provided from the rover from us, it has been defined in the user guide.
Great.
Yeah, I'll just add that if you've got a payload that's in this small package and it's bolted on the rover, it may be possible in such a small package to deploy something after the rover is already on the surface. But yeah, that'd be a real challenge too. So you have to think real hard about it.
Okay. More about the contents of your submission. Are we supposed to have electronic schematics? And if so, how detailed should they be?
Well, since we're in the ideation phase, as Saba mentioned earlier, more information is better, so as much detail as you can provide would be great. But in the ideation phase, we don't have an expectation of extremely detailed schematics, although a general schematic would be beneficial.
Yeah, and something I'll add to think about, remember what Saba had said about the technology readiness level. And so if there's components in there that are going, well, there's no path to flight for this, it's something that's never actually been demonstrated in a laboratory environment, or there's no commercial equivalent, it's not going to do well. So you're going to want to have the schematics such that you can provide confidence that this payload can be developed and fielded in this relatively short time frame. So that's something to consider when you write your schematics. So the more detailed, like Andrew said, the more detailed, the better.
Great, thanks, Kevin. So the next question I can answer, which is it possible to send a copy of this webinar later? And yes, this webinar is being recorded, and we will share out a recording within 24 hours of the webinar. The next question is about the plan for phase 2. And I know some of these details may not be finalized yet. Is there anything else you can share about phase 2?
No, we expect that the phase 2 would have substantially more funding, enough to take the top few candidates and really develop them to the point where they could start to be integrated on a launch vehicle. So we expect there to be a serious development cycle, and of course, very accelerated by NASA standards.
And like I mentioned, the phase 2 call will come out this fall. So keep an eye out for it.
Awesome, thanks, Saba. Okay, here's a question from someone that's unfamiliar with computing devices that are commonly used in payloads. Do you have any advice for them? Can they use single board computers for computing?
I would encourage them to go look at what's all the commercial products for CubeSats. There's a lot of small, relatively radiation hardened boards and processors available, specifically designed for CubeSats. Now, in some cases, depending on where you go on the lunar surface, they may not quite meet the environments, but they're already pretty good. So I would recommend just looking at some of these CubeSat component providers. There's a lot of sources out there.
Great, thanks, Kevin. Okay, so we have a question about arms for the payload or arms for the rover, and we've actually received this a fair bit on the challenge forum. So maybe Andrew, I know you were answering some of those questions. Can you just speak about what's allowed in terms of arms for the payload and if there are arms on the rover?
Sure. Well, since we don't know exactly which rover we're going to be going on, and we may be going on multiple rovers, there's no specification of whether there's an arm or not on the rover. So any entries shouldn't rely on an arm provided by somebody else. If within the mass and volume guidelines, you can create a small arm to deploy whatever you need to deploy, that's certainly a reasonable thing to do. Keep in mind that it would probably have to be fairly small and that its moment couldn't be very large. So it can't go out to maybe 20 or 30 centimeters, maybe 10 or something like that might be a reasonable number.
Great. There was also kind of an extension to this question about drilling and scoop capabilities for the payload. Is that something that's okay?
Yes, I think drilling and scooping would be great. I mean, that's a great way to do soil analysis, and we're certainly considering that for some other applications like this. So we would strongly encourage that.
Okay. Now, there's a lot of people that are either experienced in this kind of design work or actually experienced on things like payloads, but then there's also some beginners that are looking at this challenge. Do you have any tips for those people who this might be new for them? And would you ever consider an entry from someone that's a beginner that may not have, you know, great CAD drawings or electrical schematics as part of their submission?
We're certainly open to all kinds of entries. What we find is people who are not immersed in our field sometimes have much better ideas than those of us who have been studying it for a long time. So we welcome people who are new to the area. I think in the next phase, if we found one that looked really interesting, a really good concept, then we would provide some help from some of the NASA engineers to help them develop their concept so that it could be made into a flight instrument.
Awesome, thanks, Andrew. Okay, can we use capacitors as stand-in for batteries?
I don't see why not. As long as they will meet the requirements, shouldn't be an issue. Andrew, do you want to add anything?
No, Saba, that's actually your area of expertise, so I will go with Saba on that.
Yeah, I mean, if there's some reason capacitors might be good, if you know, we gave you a power requirement, but if you have a sort of a peak power draw that exceeds this power requirement, you know, a capacitor might be a good way to get a little extra oomph to shoot your laser beam or to do something like that for a short period of time.
Yeah.
Okay, great. My next question is about visual odometry. Is it possible to place the camera looking downwards? So this would put the hole at the bottom surface. I'm assuming they're mentioning the bottom surface of the payload.
I guess the cameras that we're aware of on the rovers that we're looking at will probably be forward-looking, not downward-looking. If they wanted to provide their own camera with the payload to look down, I think that could be accommodated.
Yeah, I'll just add, you know, the use of things like optical flow on the lunar terrain could be a valuable experiment because it's very hard to simulate the exact properties of the lunar terrain. And like Andrew said, the rover will have its own navigation solution if you're doing some kind of technology demo for an optical flow system. Would be a pretty cool thing if that's what you're looking at. Yeah. So I believe a camera would be something that could easily be accommodated on the bottom of the rover.
Okay, here's a question kind of connected to what you were talking about, Kevin. Will the payload get latitude and longitude information from the rover, like coordinates of their current location?
Yeah, you know, the payloads will certainly have access if they request it to any navigation pose data that's available that the rover has. You know, the rover is going to have its own sensors on it, and if the payload needs that navigation data for some reason, it certainly would probably be on the data stream that they can get over their serial interface. If, you know, so remember the rover would be the master on that, and so there'll probably be some protocol. But you know, if they set up their ICD so they would get periodic navigation data, then certainly that's something they can expect. But if they need more precision, it's up to than the rover normally has, and it's up to the payload provider to get that.
Yeah, maybe a couple more comments are due here. One, there's no GPS on the moon, at least not yet. NASA's certainly looking at ways to create a GPS kind of system for the moon, but it's not there yet and wouldn't be in place before this payload was on the surface. They probably wouldn't get latitude and longitude the way you would on Earth. What they would do is get relative distance and bearing from the lander, from where the original rover payload is deployed.
Great, thank you. So my next question, I think, might be arising from a misunderstanding from someone. So maybe you can help clarify for them. Their question is, how should we send data to the drone? Can you talk a little bit more about how this payload fits into a bigger system and why that question doesn't make too much sense in this context?
Yeah, so we're not sure what they mean by drone. Things like aerial drones, of course, won't work on the moon because there's no atmosphere. If we consider a rover a drone or multiple rover drones, the data will the rover itself will have its own transmission data, probably relayed to the lander for transmission back to Earth. And so the payloads won't be talking to themselves or to other payloads. They will communicate through the rovers.
Great, thank you. Okay. There's another question here about what the payload power constraints are. I will encourage this person to look at the Small Payload Lunar User's Guide as the place to get things like what the power constraints are. Anything that you'd like to add to that response?
No, I think they,
No.
yeah, go ahead, Sava.
No, I think we've defined the power that we'll be providing from the rover side and what you could expect. Like as someone had asked earlier, supercapacitors, as long as they will survive the thermal environment, they are allowed as well if you need to have a peak power.
Okay, great. So we just have a few minutes left for some last questions. Is there already a mechanism to pick up soil samples for the payload?
No, NASA is working on different variations on ways to sample soil, but there's none provided for this particular application. So we don't expect on the rovers that we will be riding on to have any kind of mechanism to pick up soil. So if they would like to sample the soil to do some kind of analysis, then they will have to provide a mechanism to pick it up from the ground.
Okay. Another question about phase 2. Will that development be by the competitors or will it be by JPL?
It'll be by the competitors with assistance from not just JPL, but NASA in general. Different portions of NASA will be there to assist the competitors. When we get to that phase, we want them teams to be successful, and we'll try to do whatever it takes to help them be successful.
Okay, great. How long has lunar been morning to noon in Earth days? This feels like a quiz because it's not quite related to the payload challenge, but I'm sure it's something someone can also look up.
Well, the total lunar day is about 15 days, 15 Earth days. And so from morning to noon is about 7 days as far as that goes. They don't translate that well, so it's kind of a little bit ambiguous question.
Great. Okay, will phase 2 be open to anyone like phase 1 or only to the winners of phase 1?
It'll be open to anyone. However, there'll be a strong preference given to the phase 1 entries.
Great. Okay, we have another question about rules to be observed when doing bioengineered projects. We answered this a little bit earlier, so hopefully it's clear for everyone that you should look at the planetary protection rules, but that you're allowed to proceed with bioengineered projects. Kevin, anything you'd like to add? If you have clarification that we didn't get on the first question, please feel free to post it again.
No, I don't have much to add. Like I said, one of the things, bringing things back is probably a little bit of a different story. You have to, anything that comes back to the Earth, but I wouldn't anticipate that anything will be coming back. But anything going to the lunar surface, there's not a lot of restrictions there.
Great, thank you. Okay. My next question is, what if I have a great idea, but it's not directly related to the payload challenge? There is a section in the forum where you can post your great idea that's not directly related to the payload challenge. It will not be an eligible submission for this competition, but you're welcome to share it with everyone in the community there. Okay, is there any information on potential landing sites?
No, NASA's considering a number of landing sites. The first couple of CLIPS landers are going to be in the mid-latitudes, I think somewhere in the 40s. We know that the later CLIPS landers, maybe even the third or fourth mission, are targeted for far southern latitudes. I think something like between 85 and 88 degrees south. But those selections have not been made at this time, and so that's subject to change. That's just the talking on the table at this point.
Great, thanks, Andrew. Okay, I saw this question in the forum, so I think it's a good one to ask here as well. Can you submit a multi-payload mission? For example, 2 boxes of equipment that talk to each other?
The answer is yes. If you're in the mass and power constraints, that would certainly be okay. If you want to talk to 2 different ones on 2 different rovers on the same mission, they would have to communicate through the rover communication system. Beyond that, if they needed to talk to each other, there would be some restrictions on how they could do that. Free interchange of speaking from one box to another is probably not going to be something that's easily done. It would probably have to go through the rover system.
Great, thank you. Okay, my next question. So if someone has an idea, but it's not quite at TRL level 3 yet, is that something that they can still submit to the challenge?
I think Andrew touched upon this before. Yes, I mean, we are looking for different ideas, and we will evaluate it. So all entries are encouraged.
Great. The second part of that question was, how will it affect our scoring? And I think I just encourage you to go back and look at the judging scorecard. It talks a little bit about technical maturity. So if you're, TRL level 1, you may score lower there. But you could score really highly on some of the other categories that would help you. So I certainly would not stop your submission due to that reason. And with that, we are just about at time. So I'd like to thank everyone for joining us today and sharing all of their questions. We got through a lot. So a big thank you to Saba, Andrew, and Kevin for answering these for everyone. Just a reminder that the submission deadline is June 8th, which is 1 week from Monday. So we're coming up on it very soon. If you have any last minute questions, like I said, you can post them in the forum, but please do just do a search before you post in the forum to see if they've been asked before. And with that, thank you so much, and we look forward to seeing your entries.
Very good. Thank you, everyone.
Thanks, everyone.
Thanks, everyone.
Thank you.
Thanks, Kyla.
Thank you, Caleb.
Thank you.
Okay.
Mhm.